Minasan, konnichiwa. Watashi wa Andres Almirai desu. Presentation o tanoshimi kudasai. And I will continue in English. The topic of today is building modular applications with the Java Platform Module System in Larry. So as I said earlier, my name is Andres Almirai and I work for Oracle inside the database group. One of the things that we do inside this particular group is, of course, produce the Oracle database that everybody knows, but there are other projects and products related to the database, and some of them happen to be open source, which is one of the things that I would like to talk about pretty much all the time. I love open source. And one of the projects that I'm going to see today, it happens to be open source as well. So you may have heard of the Java Platform Module System. In the early days, it was known as Project Jigsaw, and it started sometime around Java 6, so that's quite some time ago. And it was released with Java 9 close to 4 years ago, if I'm not mistaken. Now, the idea behind the module system or Project Jigsaw is to break down the JVM monolith into smaller pieces. This will allow the architects and the designers of the JDK to have better control on how they implement the features and how the whole code base interacts. Now, as time progressed, the way that the architects and the designers saw that the module system was working well for them, they thought, what if we were to open this API so that we as developers, as users, will be able also to consume said APIs and will be able to benefit from better encapsulation and better design foundations. And that's exactly what happened when the platform module system was released in 9, so that both the architects and the designers of the JDK and we as developers can have all the benefits. But there are some particular issues perhaps, or at very least some questions when it comes to talking about the module system. You might have heard of some of this. For example, there is only one version of a module allowed at any given time when you assemble an application. As a matter of fact, there is no possibility to have version numbers for modules. The specification says you should not be versioning your modules. Another thing that happens is that when we assemble applications in a modular fashion, we do this at compile time. This is great because the compiler can check the restrictions that every module descriptor has imposed on their consumers. This is what we want. This is part of the encapsulation. But if we would like to have additional modules at runtime, so load them and unload them, then we simply can't do this. Apparently, you also have to modularize all your dependencies in order to reap the benefits of the module system. Because if your dependencies are modular, that means that they have proper encapsulation. And we as consumers can figure it out if we actually can use a particular resource or a service or a package that has been exported. Now, if your dependencies are not fully modularized, you can still make use of them if they provide a manifest entry called automatic module name, which in this case simply says reserves that particular name for the module, but every package and every service will be automatically exposed or exported. So it is as if you were to have written a module descriptor where you say export everything. And if you happen to have a dependency that does not define a manifest entry and does not define a full module descriptor, then the JVM will still treat it as an automatic module name where the name is given by the article file, the jar file that contains the module. Sometimes the name matches as we expect and sometimes it does not. So at the very least, we should be looking at defining automatic module name if you are not yet ready to jump into the full module system. It is also a bit hard to map a dependency coordinate to a module dependency. So by dependency coordinates, we are referring to the typical Maven coordinates, which is group ID, artifact ID, and version, into what is a module name. Now, there have been some approaches, but right now there is a convenience that we have one single module definition per jar file. And finally, you may have encountered that when you are working with full module descriptors, even so there are some packages that may not be exported. If they are found in more than one jar file, then this is known as a split package. So this happens for both exported and non-exported packages. When this happens, the compiler will immediately stop compilation and output a warning, actually an error, saying you cannot have split packages. You must have a package in one single module, and that's it. In the class path, we used to have split packages, and partly that wasn't much of a problem, but that actually led to some class path issues. So that's the reason why the module system says we should only have one package per module. So, is it possible to fix some of these problems? Well, yeah, you might have heard of OSGI. It is a specification that has been running for many, many years, but today we are not going to talk about OSGI, we're going to talk about the module system coming from the JVM. So, it so happens that there is an API called the module layer, which is also part of the Java Platform module system. And apparently, we could use module layers to tackle or to solve some of the issues that were just mentioned. If you were to browse to the Java doc of the latest JDK, in this case should be Java 16, you will find out this class called a module layer. And what it says is that if you construct a series of layers, you can actually construct a hierarchy of layers. And each one of these layers has different modules definitions. You could construct also a class loader per module layer in such a way that you end up with a hierarchy of class loaders, and each layer then will give you some sort of isolation, the minimum isolation within modules. And that's exactly what we are going to do. Now, here is the layers API as it is right now. So basically what we're going to do is bootstrap some class loader and then put a definition to certain paths in your file system. In this case, it will be the module foo and the module greeter. Notice that we are referring to the artifact jar files. And then in step number 3, what we do is we assemble that configuration by passing the module names that we expect to be inside each one of those jar files. And then the final step, we assemble a class loader that can, well, actually we have, yes, it's as a module layer that has a single class loader that will allow us to load classes from the modules that we previously defined. Now, this API is not so bad. I mean, we're just talking about a few jar files, but the moment that you start to grow your application in size and you add more modules, then you will see that, well, there will be more jar files and more modules. Now, the other thing that happens here is that the expectation is those jar files, foo and greeter, must exist in your file system before you actually run this code. If that is not the case, then of course, there's going to be some sort of exception. There is maybe some null pointer, maybe some IO exception, whatever. The thing is that the application is not going to run. So if we were to break down an application like this, say for example, we're going to use some sort of gap coordinates for this. So we have the group ID com example, and the artifact ID is app, and the version number is 100. So we have this module app that has two dependencies, the module foo and the module bar. Foo and bar have a common dependency, which is the log4j API. So this is fine. They depend on the same version, the same gap coordinates. But notice that foo depends on greeter version 1 and bar depends on greeter version 2. If we were to put this on the class path, then this is going to break. If we put this in the module path, then the compiler will immediately tell us, no, you cannot do this because you have a split package, given that greeter supposedly may have the same package definition between version 1 and version 2. So, can we solve this? Yes, we can. And this is where the Larry project comes in. Now, the Larry project is the brainchild of Gunnar Morling, fellow Java champion working for Red Hat as an open source software engineer. He is the current lead of the Division project, which is a change data capture solution for databases. And he is the spec lead of the Beam validation specification as well. Now, remember the example that we saw before, and remember the API that we had to use in order to load modules. Well, now, this is what we can do using Larry to create an application using different modules. Notice that we have the base layer or the lock layer when we define the log4j API, and then we have the full layer that has a dependency on greeter module version 1, and we have the bar layer that depends on greeter version 2, and then we also have the app layer that depends on both foo and bar. We define an entry point, which will be the app main class, and we pass on parameters. Now, the advantage of this is twofold. First is that Larry will allow us to define these conflicting modules and put them in different layers. But also, notice that the definitions of the modules are not the module names, but they are actually the gap coordinates of the jar files. So what Larry is going to do for us is figure out if we have these gaps, if we have these dependencies in our file system. Apparently, you may be using Maven as it is to download all these jar files. And if they are found, then they will continue, will proceed, and will assemble the application using different layers. As it turns out, Larry is just a tiny, tiny abstraction on top of the whole API, set of APIs that the Java Platform Module System gives us. So of course we can still use the module layer API directly, but Larry gives us some additional capabilities. So here's another one. So given that there is some sort of repetition with how the API is used, so by saying I want to use the module foo with version 1 and some group ID, if we were to using Maven, then you will see the same dependencies in your POM file. Is there a way that we can reduce that repetition, at the very least make no mistakes where the version number changes? Well, yes. So Larry supports external configuration via different file formats. The first one that we're going to see is this. This is exactly the same example that we saw before, but in this case is using external configuration file using the YAML format. So we have the same number of layers with the same configuration for all the modules as before. So there is the log layer with the log4j and the full layer that has a dependency on log. Notice that has a reference to parents and depends on greeter 1 and the full 1, and the bar layer, which depends on greeter 2 and bar 1, the app layer that has a dependency on foo and bar, and we have an entry point, and that's it. But if you are like Bruno Borges and you think, well, YAML is not very good because, well, significant white space, it's very easy to mess it up with a single space, there are other formats that we support. For example, TOML. TOML is another hierarchy format, very similar to YAML, but it does not rely on significant white space. So if you want to use indentation or not, it's up to you. But in this case, we are showing that it's exactly the same configuration as before. Now, even though we are now externalizing our configuration, we still have some repetition if you were to use Maven to build your application. Well, because there is the group ID, artifact ID, and versions of your dependencies. If we were able to parameterize this external configuration, that would be good, right? Well, it so happens that we support parameterization of all the external configuration files. So here's another application. This is actually the application that I'm going to demonstrate today. Notice that in this case we have 3 layers with the names JavaFX, Course, and Plugins. And there are some interesting value placeholders here, if I want to say something like that. For example, there is the project version, Larry version, TilesFX, and JavaFX version. So these values, these keys will be resolved for a secondary properties file that we can supply when running Larry. So in one hand, you have the JavaFX toml or JavaFX layer or layers, whatever name you want to give it to your layers configuration file. And the second file is called, also could use any name, but has to follow the properties format, the standard Java properties format. Well, we see the key values for each one of these things. And there we see project version, JavaFX, TaskFX, and Larry version, which matches the name that we saw in the toml file. There is one other name that is not matched automatically by the versions properties, but it's also matched by the Larry launcher itself. It so happens that for JavaFX artifacts, they are bound to a specific platform, and the name could be either Mac or Win for Windows or Linux for Linux. Now, Larry is able to detect that particular platform that you're running on and provide a suitable value for the OS detected JFX name placeholder. So the only thing that you need to do if you rely on JavaFX is just use that particular value. Now, how do we launch an application using Larry? There are a couple of ways that we have at our disposal. So we published the first alpha release, when was it? In January 30th of this year, 2021. And this gives you the basic capabilities for assembling the application and running it with Larry. So you see that there are a handful of files that are related to this release. There is a zip file or a targc file or a shaded jar that contains the launcher plus all the dependencies. So you can either download the jar file and then just pass in the configuration. For example, well, if you just do not pass any properties, then it will immediately tell you what are the options that you can use. So for example, there's layers config when you pass in the configuration file, and you can also have the properties section for passing versions properties if you have it. The other way that you can do, you can run Larry is by downloading the zip file and configuring the path, or you could rely on SDKman that does it for you. So Larry is published via SDKman as well. So you can install as any versions that will be eventually published by Larry and switch from one another very easily using SDKman. And once you have Larry installed, notice that now you have the Larry command that takes in pretty much the same configuration that we saw with the jar file. Or if you do not have SDKman or you don't want to use SDKman, then there is also the option of JBank. JBank is another interesting tool that exists out there that allows you to run Java source files with dependencies, but can also resolve any kind of Maven dependency for many different Maven repositories, such as the Maven Central repository. So what we do here is, well, you can use SDKman or many other ways to install JBank, not just via SDKman. And once you have it, then you point JBank to a specific URL, which is the Larry@Moditech kind of URL. This is known as a JBank catalog. What happens under the covers is that JBank will detect what is the actual script that needs to be run, download it, download all the dependencies, and then launch it. So basically, this Larry@Moditech is another way for you to instantiate and to launch the Larry launcher. So now you have it. There are a few ways that you can have it instead of, or just you can build your own Larry launcher if you want to. So far, we have referred about our dependencies as being available at remote repositories such as Maven Central or any other remote repository that you may have configured in your settings XML file. But what if you wanted to constrain the execution of your application to a set of jar files or dependencies that only exist in your local file system, and by any means also disable any kind of network operation? Well, turns out that you can. We have a feature called local repositories that allows you to define dependencies in the local file system using two different formats. One of them is called the flat format or flat layout, and the other is the default layout. In order to activate this feature, the only thing that we need to do is add a result block to your configuration file and define as many local repositories as needed. You have to supply the layout, which is either again flat or default, and then a path to that particular repository. It may be an absolute path or maybe a relative path, and if it's relative, it's going to be relative to the current configuration file. So here are two examples of the repository layout. The first one is the flat repository, where we have one directory that contains every single jar file, and the default repository that follows the conventions from Maven Local and Maven Central, which uses a series of directories starting with the group ID separated by dots, so that's com example, and then the name of the artifact, so that will be foo, then the version number, so 100, and finally the jar file. So if you use either of those two layouts, then Larry will be able to find all your dependencies. What if we wanted to turn it completely 180 degrees around and go completely remote? So not just having your dependencies be remote, but also your configuration file be remote. This is known as remote layers. The idea of remote layers is that your configuration file, including your properties, and this is optional, will be hosted at a remote location. It may be an HTTP server or an HTTPS server. Whatever it is not originally found in your local file system. You can mix in remote and local repositories. So if you want dependencies to be resolved by Maven Central or resolved by any of those local repositories options that we saw before, then you can do so. There is one catch though, and that is that any dynamic plugins that your application may rely on must exist locally. So there's no possibility of remote plugins. And while I'm in the topic of plugins, let me show you what I mean by that, which is the other feature called plugins or plugin architectures. As a matter of fact, this is the feature that made me have a look at Larry and see how we could create applications that can be updated while they're running, but in a safe manner by using the module system. In order to enable loading plugins at runtime, Larry has an interface or exposes an interface called the plugin lifecycle listener. And depending on how you configure your application, it will listen to local changes into the specific directories that you configure. Once a new plugin or application plugin has been detected, has been added into that directories that are being watched, then the method called plugin add will be triggered, and this is where you can react. And if a plugin gets removed, then the method plugin remove will be invoked and your application again can react and do any kind of cleanup that is needed. So when you implement this interface, it is recommended that you use the service loader utility. This is a standard utility since JDK 6, if I'm not mistaken. The catch is that instead of just using the load method and passing the type, in this case my service is an application specific type, it's a class that you have defined, you also pass in the module layer of the plugin. This will ensure that all the interface implementations of the my service type will be found, but notice that it will find everything in the module hierarchy. So if we want to constrain just those instances that are provided by the plugin that was added, then we still have to do this filtering in lines 9 to 11. So this is typical. Now, let me show you a demo of what is going on. Now I'm going to turn into the terminal, and I have an application that is the JavaFX application that we saw earlier. So I can show you inside staging, I have this configuration file. This is the application that has some placeholders and expects some jars to exist either in Maven local or Maven central. This application has not been yet published to Maven Central, so if I do a build and install locally, I will ensure that all the jars are available when I run Larry. While this is going on, yeah, it's done. And running, let's see which version of Larry I'm running. I believe is the latest snapshot version. That is correct. You can check that by just invoking Larry version or just asking SDK man to list all the Larry versions that are currently available in my system. Why I'm running a snapshot? Is because there was a particular issue in the remote layers feature, which has been fixed, but not yet published. And that's the feature that I want to showcase today. But I'm getting ahead of myself. So now I'm going to run Larry for the first time. And I'm going to pass the layers configuration file, which is found inside staging. So that's the file that I showed you. And I also pass in the properties so that it knows how to resolve the versions. I'm gonna run it in the background. And this will open a new window that looks like this, right? And now, if I look inside the staging directory, like this, we see that I have some jar files and some zip files here, which are in this directory called plugins prepare. This directory is not being watched by Larry. The directory that is being watched is plugins. Because if we look again at our configuration, there's this layer called plugins. We could use any name we want to. I just chose plugins. And the directory could also use any name we want to. I just again chose plugins. And that directory is currently empty. But notice what happens. When I copy a plugin definition like this one, plugins prepare, from the outside world, clock in jar, into the directory that Larry is currently watching, like this. Now I have a clock. I can copy from other formats. For example, let's copy now the zip file into plugins. And then we have that. And I can copy from the tar file as well into plugins. Now, why do we support different formats? It's because the jar format is supposed to be just one plugin with no dependencies, or maybe you have shaded dependencies. But if you have a plugin that requires more than one jar, so not just the plugin, but any other dependencies, then we recommend to use either the zip or the tar format. Now, notice what happens when I remove one of these plugins from the watch directory. So let's remove the one in the middle. I can remove the sparkline as well. And now it's gone. And this just happens while the application is running, and it uses the module system. So let's kill that application. Let's close it down. And now what I'm going to do is remove from Maven local all references to the jar files. I think is org and cordam files. Yeah, let's remove everything. Right. Oh, of course, do it like this. Now, if I attempt to run the application as before, when we have it like this, type it like this, I will expect this to fail because there are no longer any jar files in a Maven repository. And yep, failure. But if we use the local repositories, and for that we're going to use a different configuration file. Notice the difference here is that we are pointing to a flat repository that has these names. Now that flat repository is found here in staging. This is the one that contains all the jars. So if I were to run the application now with a different configuration file, so let's call this local, and run it in the background, I will now have a window that looks like this because we had a previous plugin. Now we can tell that it's actually working if we add more plugins to it. Plugins prepared, and we copy the gauge like this. We copy the zip file into a staging plugins, and it continues to work. So we can close this down. And finally, let me show you the remote version. Now for this to work, we need two things. We need we may need the dependencies provided by a remote Maven compatible repository. In this case, I push them to GitHub packages. So this is my personal GitHub packages repository where I have all the jars that I need to run the application. And I also have a remote configuration here, a remote configuration file. This file, if we were to have a look at it, it will tell me that I need to use this settings XML file. Why? Because I need to configure the reference to this Maven compatible repository. Also, I need to add a GitHub token so that I can resolve these dependencies, otherwise it will not work. I have everything already done locally here. If we look into staging, there is this GitHub settings XML file. We can have a look at it. Looks like this. It's just like any other regular Maven settings file. And we have the definition of two repositories. First, I list Maven Central. And second, I list GitHub. And that's the URL for the repository. And some credentials. Of course, I'm not going to expose my credentials, but they are found in an environment variable. So once I have this, I can say Larry layers config and copy the remote here, this URL, copy it, paste it here, and then say properties. If I want to, I can use the remote properties, or I can just use the local properties, and I can say staging. And because I have plugins, I also have to specify what is the current directory where the base is. In this case, it's going to be staging. Okay, you will see when I run this application, there will be a series of errors. This is because we have listed Maven Central first, and then GitHub. What happens is that Larry will try to resolve dependencies from Maven Central. And because these dependencies are not there, I just noted a typo here, then there will be a failure, and then it will continue with the next server. In this case, is going to be the GitHub packages. So let's see that in action. There is, could not find from Maven Central, but the application continues, and it pops up the window. So this proves that the resolution of layers happened remotely, and it downloaded all the required jars from my GitHub packages repository. All right, so we can end this now, and let's go back to the presentation. Now the fact is that if we add and remove layers as it is, there is bound to be problems with class loading, or we expect to see some problems with class loading if we are not doing things correctly. Now, as it happens with this CharFX application, we had a memory leak at some point, because you remember that the window had some animations. Well, it does it by using a background thread. When we were removing the plugins or unloading the classes, we forgot to stop that thread. And the end result is that the thread kept a reference to the plugin class. So no matter how many times we were adding or removing plugins, we actually have more references and we have this memory leak. But luckily for us, Larry has integration with JFR, with Java Flag Recorder. And it will publish events whenever a plugin gets added or whenever a plugin gets removed. Now you could use these events to match with with class onloading and class loading events also tracked by JFR. So in this case, we're seeing we could use JDK mission control to go through the different events that JFR has triggered. And this is an investigation that Gunnar did in order to figure out how Larry was behaving. And it turns out that we eventually found that we have this memory leak because we had expected to see 3 events of class loading and class unloading, but it turns out that there were more than those events, and we didn't see exactly what we wanted. So he used a different series of tools, such as, again, mission control and a few others, and he eventually found the problem, and we discovered that we just needed to stop the thread and then do the unloading. And well, so there is a blog post when he goes in further length to show how he used the different tools and how the different events published by both Larry and the JVM will allow you to figure out what was going on. So what is coming in the future for Larry? Well, there is already one fix that is in place for the remote layers that I discussed. But there are a few other things. So if we have a binary distribution that can be installed using SDK man, but if you want to install it using other tools such as Homebrew for Mac or Snap for Ubuntu or Chocolate in Windows or any others, then we're going to offer those options. There may be another opportunity to package an application on something known as a capsule, which is a zip file or a jar file that contains all the dependencies you use local repositories, any other resources that may be needed, and of course the layers configuration file. And this zip file or jar file will be self-executable in such a way that you just need to run it and it will automatically know what to do, how to configure itself, and then launch your application for you. Or we may also be looking into custom Java runtimes using JLink. There is still a little bit of repetition with the external configuration file. We may be looking at options to harness the information that is already found in a Maven configuration file so that either the external configuration for Larry gets generated based on the POM files or there is more parameterization that we can take up. Right now, the only API that Larry exposes to your application is the plugin lifecycle listener. And it may be the case that we will be able to expose other APIs. So for example, if you want to know how the application has been configured as a read-only mode for the layers, then we will see how we can make this happen. And we also be looking at what other JFR events may be of a good idea to continue exposing so you have better diagnostics when running your application. Or if you have any other ideas of if you have encountered any problems with using the Java Platform Module System and if there is something that the module layers can solve, well, just let us know. Here are some resources for you. The first link is the project itself, also Larry, that contains the source code. And the second repository contains a series of examples. The JavaFX example that we saw today is found there. We also have an example using Vertex showing that Larry can be used in server-side applications as well. It's just Java anyway. And the example, the first one that we saw earlier with the foo and bar and conflicting modules is also found there. Few other resources, Gunnar has posted, have a set of blog posts. The first one is announcing the project. The second one is showcasing what is the idea behind plugin architectures using Larry. The third one is the investigation behind the memory leak that we have in the JavaFX application. And the fourth one is the announcement we made when the first release of Larry came out. So everything that we saw today is open source, and it's very easy to contribute to open source. Just open a ticket whenever you encounter a problem. And that's it. If you have the time and you have the passion, you can also supply source code. But at the very least, just open a ticket. And I believe this is everything that I have for you. I enjoy pretty much. I hope that you also enjoy it. And if you have any questions or comments, please let me know. So, どうもありがとうございました。